First, let us learn about the empty set. Consider the set A is equal to X, such that X is a student of class 11 presently studying in a school. Thus, the set A contains a finite number of elements. We now write another set B as B is equal to X, such that X is a student presently studying in both class 10 and 11. We observe that a student cannot study simultaneously in both classes 10 and 11. Thus, the set B contains no element at all. So now we can define an empty set. A set which does not contain any element is called the empty set or the null set or the void set. According to this definition, B is an empty set, while A is not an empty set. The empty set is denoted by the symbol phi or opening closing curly brackets. We give below a few examples of empty sets. 1. Let A is equal to X such that 1 is less than X is less than 2. X is a natural number, then A is the empty set because there is no natural number between 1 and 2. 2. B is equal to X is such that X square minus 2 is equal to 0 and X is a rational number. Then B is the empty set because the equation x square minus 2 is equal to 0 is not satisfied by any rational value of x. 3. C is equal to x such that x is an even prime number greater than 2. Then C is the empty set because 2 is the only even prime number. 4. D is equal to x such that x square is equal to 4. X is odd. Then D is the empty set because the equation x square is equal to 4 is not satisfied by any odd value of x. Now let us learn about finite and infinite sets. We observe that A contains 5 elements and B contains 6 elements. How many elements does C contain? As it is, we do not know the number of elements in C, but it is some natural number which may be quite a big number. By number of elements of a set S, we mean the number of distinct elements of the set, and we denote it by ns. If ns is a natural number, then S is a non-empty finite set. Consider the set of natural numbers. We see that the number of elements of this set is not finite, since there are infinite number of natural numbers. We see that the set of natural numbers is an infinite set. The sets A, B, and C given above are finite sets. Now we are in a position to define finite and infinite sets. A set which is empty or consists of a definite number of elements is called finite, otherwise the set is called infinite. Consider some examples. 1. Let W be the set of the days of the week. Then W is finite. 2. Let S be the set of solutions of the equation x square minus 16 is equal to 0. Then S is finite. 3. Let G be the set of points on a line. Then G is infinite. When we represent a set in the roster form, we write all the elements of the set within braces. It is not possible to write all the elements of an infinite set within braces because the number of elements of such a set is not finite. So we represent some infinite set in the roster form by writing a few elements which clearly indicate the structure of the set followed or preceded by 3 dots. For example, 1, 2, 3, dot, dot, dot is the set of natural numbers. 1, 3, 5, 7, dot, dot, dot is the set of odd natural numbers. Dot, 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 minus 3, minus 2, minus 1, 0, 1, 2, 3, dot, dot, dot is the set of integers. All these sets are infinite. Now let us do an example. State which of the following sets are finite or infinite. 1. X such that x belongs to n and x minus 1 into x minus 2 is equal to 0. Solution. Given set is equal to 1, 2. As 1, 2 is the solution of equation x minus 1 into x minus 2 is equal to 0. Hence, it is finite as elements are countable. 2. X such that x belongs to n and x square is equal to 4. Solution. Given set is equal to 2. As 2, minus 2 is the solution of equation x square is equal to 4. But only plus 2 is a natural number. Hence, it is finite as elements are countable. 3. X such that x belongs to n and 2x minus 1 is equal to 0. Solution. Given set is equal to 5. As no natural number can be the solution of equation 2x minus 1 is equal to 0, as its solution is 1 upon 2. Hence, it is finite as elements are countable. 4. X such that x belongs to n and x is prime. Solution. The given set is the set of all prime numbers, and since the set of prime numbers is infinite, hence the given set is infinite. 5. X such that x belongs to n and x is odd. Solution. Since there are infinite numbers of odd numbers, hence the given set is infinite. What are equal sets? Given two sets A and B, if every element of A is also an element of B, and if every element of B is also an element of A, then the sets A and B are said to be equal. Clearly, the two sets have exactly the same elements. Let's define equal sets. Two sets A and B are said to be equal if they have exactly the same elements and we write A is equal to B. Otherwise, the sets are said to be unequal and we write A not equal to B. We consider the following examples. 1. Let A is equal to 1, 2, 3, 4, and B is equal to 3, 1, 4, 2. Then A is equal to B, as they have exactly the same elements. 2. Let A be the set of prime numbers less than 6 and B the set of prime factors of 30. Then A and B are equal since 2, 3 and 5 are the only prime factors of 30 and also these are less than 6. Now let us do an example. Which of the following pairs of sets are equal? Justify your answer. X, the set of letters in alloy, and B, the set of letters in loyal. We have X is equal to A, L, L, O, Y, and B is equal to L, O, Y, A, L. Then X and B are equal sets, as repetition of elements in a set does not change a set. Thus, X is equal to A, L, O, Y is equal to B, as they have the same elements. 2. A is equal to N, such that N belongs to Z, and N square less than equal to 4, and B is equal to X, such that X belongs to R, and X square minus 3X plus 2 is equal to 0. Solution. A is equal to minus 2, minus 1, 0, 1, 2 from the definition of set A. As these are integers and their square is less than equal to 4. B is equal to 1, 2 from the definition of set, as 1, 2 are the solutions of the equation x square minus 3x plus 2 is equal to 0. Since the elements of A and B are not same, therefore sets A and B are not equal.